Hello everyone to the second video of data preprocessing. So let's see that what we will learn in today's lecture. First of all, we will see what is data transformation. Then we will learn about transformation for categorical variables and how to do it. So as we know that the process of changing data from one format such as a database file, XML format, or Excel spreadsheet into another is known as data transformation. Transformations often require transforming raw data sources into formats that have been cleaned, validated, and are suitable for use. Data integration, data migration, data warehousing, and data preparation are all steps in the data management process that need data transformation. So let's see that how we can do transformation for categorical variables, or why is it important. Let's say that for a particular data science or machine learning business problem, we are only dealing with the structured data, and the data collected is a combination of categorical and continuous variables. In this case, the majority of machine learning algorithms will not understand or be able to deal with the categorical variable. In this case, the majority of machine learning algorithms will not understand or be able to deal with the categorical variables, meaning that when data is supplied to a model for training and testing as a number rather than a categorical, machine learning algorithms will perform better in terms of accuracy and performance measures. Now that we have a defined goal, we must transform or encode categorical data to numerical values prior to developing any statistical models, machine learning, or deep learning models. Before going there, let's learn the two kinds of categorical data which are listed below. So first of all, we have nominal scale. The nominal scale is used to label variables and refers to variables that have only been named. It should be noted that a nominal scale only refers to variables with names. Keep in mind that none of these scales have any numerical meaning and nominal data are not ordered. Let's see an example. Imagine a season column with four variables or labels: winter, spring, summer, and autumn. So this example is of nominal scale as we don't see an order in all of these seasons. Next, we have ordinal scale, a variable that captures the value of the data from an ordered collection is known as an ordinal scale. An example of ordinal scale is below. Imagine a review column with four labels: very good, good, moderate, bad, and worst. You can see that all of these are in an order, and hence they represent an ordinal scale. Now let's move forward. It's time to see the encoding techniques for transforming categorical variables. We are all well aware that the majority of machine learning algorithms only function with numerical input. Because of this, categorical features must be encoded into a representation that works with the models. Therefore, we shall discuss a few well-known encoding techniques. So first of all, we have label encoding. Then we have one-hot encoding. And in the last, we have dummy encoding, which is also part of one-hot encoding. So first of all, today we will see about the technique of label encoding. Python's label encoding technique substitutes a numerical value between 0 and the number of classes minus 1 for the category value. For instance, if there are 5 distinct classes represented by the categorical variable, we use 0, 1, 2, 3, and 4. Let's understand this with the current example of credit card fraud detection. So first of all, I will open the Jupyter Notebook. Now I will open the folder of Introduction to Data Science. Then I will open Data Preprocessing. And here I will create a new notebook with the name of Data Preprocessing Part 1. Let's rename it. So as we know that the most important step is to import the libraries, and I will say import numpy as np and import pandas as pd. Then I will say from sklearn dot preprocessing import label encoder. I have used the package of sklearn and then preprocessing to import the label encoder. Let's run it. Now let's use a markdown for reading CSV file. I will say hr data equals to pd dot read CSV, and the name of file is hr_data.csv, which is actually a comma separated file. Let's run it. Now I will say hr_data.head to see the columns. All right. Now I will generate a little summary of the dataset by saying hdata.info. Let's see. So we have two float columns, 6 integers and 2 objects. The last 2 columns are objects, which is department and salary. Now here you can see the column of left, which is the target variable, but we can see that the target variable is in the middle of the dataset. So why not put it in the last? Let's do it. I will say hr data equals to hr data dot columns dot to list, and I will save all of the columns into columns variable. Now I will define a new position by saying new position equals to 10. Now you might be thinking that why I have used 10. As you can see that we have 10 number of columns: department, salary, promotion, last 5 years, and so on. Now we have the target variable on this position. I will pop out this column from this position and place it on to the 10th position. That's why I have used 10. So I will say columns dot insert, and then I will say new position and insert whatever I will pop out into the new position. Now what I want to pop out is columns dot pop and pop the value that is on the columns dot index of left. Now I will say hr data equals to, and I will say store this column into hr dataset. Let's run it. Now I will say hr data dot head to see the changes. That's great. As you can see, the target variable is on the last. So this is much comfortable. Now let's do one more thing. I will say HR data dot columns equals to HR data dot columns dot str dot lower dot str dot replace. Now here I would like to replace the spaces in columns names with an underscore, and I will convert all of the column names into lowercase. Now let's say HR data dot head to verify the changes. It looks pretty good. Now here I would like to use the function of group by. I will say HR data dot group by, and I want to group my dataset by the column of salary dot mean. All right, as you can see that we have three labels in salary: high, low, medium. So these are ordinal data. Now I would like to use the technique of label encoding here. So first of all, I will create an instance of label encoding class by saying le equals to label encoder and store it into le. Now I have to create a list of categorical columns for whom I want to use label encoding. Let's say for the meantime, I use salary because this column is not only a categorical column but also have ordinal data. So now I will say HR data equals to HR data and take this column cat and apply the technique of label encoding to transform this categorical variable by using le dot fit transform. Let's run it. All right. Now let's display HR data dot head to see what changes we now have. Now you can see that the column of salary have the values in the form of integers. Now, as you can see above here, that salary has high, low, and medium labels. The label of low is replaced by 1, and the label of medium is replaced by 2. And similarly, the label of high is replaced by 3. Now let's go back to slides. So this is the end of today's lecture. You have learned how to use label encoding and when to use it. Here is your homework. I have placed the link of dataset here, and these are your tasks. Clean your data, then do some exploratory data analysis, and in the last, do label encoding for categorical variables. Now good luck, see you next time.